Are we on? Okay, just I'm not seeing us on the, oh, now we are. Okay then. Hey there, everyone. So, good afternoon. And today we are going over our pilot study. Our objective was to determine if the scrub, mesic flatwoods, or the scrubby flatwoods within the UCF Arboretum sequester the most carbon from the longleaf pines within that ecosystem. And we also wanted to see how might burn intervals impact this as well. So for people who are unfamiliar with Florida fire ecology, it should be noted that burn intervals are that when they're shorter and they aren't exhausting the nutrients in that area, that's when we see optimal plant growth within these ecosystems. And that is due to how prevalent fire has been in shaping the Florida ecosystem. So when we began this research, we looked into our literature and we made an assumption that the mesic flatwoods would sequester the most carbon due to the frequency of its burn intervals in comparison with the other ecosystems. So for comparison, the scrub ecosystem usually has a burn interval of 10 to 20 years, mesic has 2 to 4 years, and then scrubby flatwoods has a 5 to 15 years. But when we went into the field and we collected our data, we were actually proven wrong with our hypothesis. We found out that the scrubby flatwoods sequestered the most carbon, and that was partially due to a management decision in the past, which we will go over later. But because of this, it's becoming increasingly important to study these ecosystems so that forestry management can update their practices so that they can more efficiently sequester carbon. Now I'll hand it over to Jordan so we can talk about the plot history. Jordan?
Okay, for this study, we surveyed 3 different plots in the Arboretum, which are highlighted in Figure 4. The first plot contains primarily upland scrub and is shown in yellow. It is about 11.4 acres in size and was most recently burned on January 9th, 2019. The second plot contains primarily mesic flatwoods and is shown in green. It is about 11.7 acres in size and was most recently burned on April 27th, 2020. The final plot contains primarily scrubby flatwoods and is shown in gray. It is about 8.1 acres in size and was previously burned on March 12, 2019. This plot also has 2 important factors in its history that affected our results. The first is that when UCF was being developed, logging was done in the area that would become UCF Arboretum. Plot 12C was largely untouched due to the large number of juvenile trees that were found there. The second is that the plot's burn interval is actually every 3 to 5 years, and as mentioned, was burned recently. Now that we've established where we did our survey, I can hand it over to Alec to explain how we did it.
So like Jordan said, we split our research area into 3 different plots within the UCF Arboretum. Each of these 3 plots represented a different kind of longleaf pine ecosystem: scrubby flatwoods, mesic flatwoods, and scrub. Before collecting data, we had to determine whether a tree was in fact a longleaf pine and not some other kind of species common in Florida. And we did this with 2 methods. Our first method was to look for a candle, which is an enlarged bright white apical meristem, which is present only on the tips of longleaf pine branches. So if you see one, you know it's a longleaf. If we couldn't find a candle, then we would look at the tree's fascicles. Longleaf pine fascicles typically split into 3 needles, while most other species typically split into 2. So just to be sure, we collected about 4 or 5 samples from each tree, and if all or the majority of them split into 3 needles, then we were pretty sure that it was positively identified as a longleaf. Once we determined the species, we could start collecting our data, which included diameter breast height for each tree, which we measured using a DBH tape, the total tree height, which we determined using a clinometer, the base height of the tree, which is the height of the tree from that first live branch down, and the live height, which is the height from the first live branch up. We also determined canopy diameter, percent crown missing, and crown light exposure, which is primarily a measurement of the competition with local trees. So for the mesic flatwoods plot, we collected data on 220 longleaf pines. For the scrubby flatwoods, we collected data on 117 pines. And for the scrub, we collected data on 44 longleaf pines for a total of 381 trees with data collected. Once data collection was complete, we inputted our numbers into iTree Eco V6, which is a data quantification software made by the USDA. And it provided us with results detailing the amount of carbon sequestered from each ecosystem, as well as the monetary value of the sequestration. We also calculated basal density, which is pretty much just the area of a tree's trunk at breast height. And we did that by squaring the tree's diameter and multiplying it by 0.005454. So our results. The first ecosystem surveyed, the mesic flatwoods in figure 4, had a basal density of 4.77 square feet per acre. Its average DBH was 8.47 inches, and it had an average tree density of 10 trees per acre. It provided 181 pounds of carbon storage per acre, as you can see in figure 2, and its total monetary value of sequestration was $1,170. In the second ecosystem, scrubby flatwoods, it had a basal density of 17.5 square feet per acre, an average DBH of 10.4, and a tree density of 27.2 trees per acre. It provided 668 pounds of carbon storage per acre, and monetarily, that is worth about $2,980 of carbon storage per acre. And the final ecosystem surveyed, scrub, had the lowest basal density of 2.3 square feet per acre, an average DBH of 9.9 inches, and a tree density of 3.9 trees per acre. It provided just about 81.2 pounds of carbon storage per acre, which totaled about $514 of carbon storage. As shown in the results, scrubby flatwoods, surprisingly, had the highest level of carbon storage across all 3 ecosystems, as well as the highest basal density, the highest average DBH, and the highest tree density. All ecosystems combined provide a total of $4,664 worth of carbon storage. And I think Jordan is gonna go over the discussion.
Mm-hmm. Our main takeaway from this study is that the UCF natural lands should be preserved for their carbon sequestration capacity. These 3 ecosystems provide almost $5,000 worth of carbon sequestration at little cost to UCF. As James mentioned, our hypothesis did not match our results. The scrubby flatwoods ecosystem held the most carbon rather than the mesic flatwoods. This is due to logging that occurred in the UCF natural lands in the 60s. All of the mature trees in the mesic flatwoods were cut down, while the juveniles in the scrubby flatwoods were left untouched. This resulted in large numbers of mature trees in the scrubby flatwoods that are currently choking out the growth of juveniles. If this study was conducted again when all of the mature trees have died, then the carbon sequestration would be much lower. Lastly, we noticed that the carbon sequestration in the scrub was lower than the other ecosystems. Because of this, we recommend focusing on preserving the large number of endemic species in this rare ecosystem rather than trying to optimize its carbon capacity via prescribed burns. That's it.
Okay, we have a question from Danny Young. Did all 3 ecosystems express a standard stem density / basal area? Seems like the one with more plants sequestered more. Did you measure sequestration per basal area?
So when we were looking into the study, we found that the scrubby flatwoods had a larger basal density than any of the other units, but we believe, or as we explained earlier, it was the forestry that was cutting down all the more mature longleaf pines and the other ecosystems as well. And that is most likely the reason why we had a higher basal density in that area.
So the answer to did you measure sequestration per basal area is no.
Yes.
Okay, good. That is all the questions so far. Yeah, I really like this study.
This was a very fun study to do as first-time researchers. Me and Cherie had gotten sun poisoning when we were in the scrub ecosystem looking for longleaf pines. It was a very fun first-time research experience with rattlesnakes everywhere.
Yeah, I can imagine. Although, I mean, seeing a rattlesnake is kind of a treat for me. But it's a little scary. All right, there's no other questions. So if you guys have anything you'd like to end with or anything else you'd like to say?
I do not believe we have anything to end with if no one has any other questions.
All right. Well, thank you guys so much for your research and for presenting at our conference and caring about our native plants.
Thank you for having us.
Thank you.
All right. Have a great rest of the
Have a great
conference.